Alrighty, so we have one more topic to cover to finish the second exam. Now this video will just go over every single metabolic equation that she asked, and I'll go step by step how to solve each equation. And when you know how to solve, this is a worksheet of 8 metabolic equations. And when you know how to solve, well, I'll just show up. And when you know how to solve each of these, there's nothing else you can ask. It's like a math thing. Once you know how to solve one algebra multiplication problem, you can usually solve all of them. They'd use the same exact steps. There's just different types which you can ask. Now, metabolic equation formulas are just used in order to calculate based on the weight, how fast they're walking, whatever the intensity, to calculate either the VO2 or calculate how much calories are burning or how long they have to work to burn a certain amount of calories. And before we get to this, there's things that you have to define because she'll give you the formulas. You just have to understand the conversions. There's certain formulas based on if they're walking, running, or if they're doing a cyclogometer, or if they're stepping, but you have to memorize the conversions because you have to convert the pounds to kilograms, the miles per hour for walking on treadmill to meters per minute. So like the metric units and not the stupid American units that no one uses in the world. But the most important thing you have to understand is that MET is equal to 3.5 milliliters per kilogram per minute. Now this is a measure of VO2, milliliters per kilogram per minute. This is the most likely VO2 you see when you see like athletes that have 80 or every single video I've been talking about was using this measure of VO2. The number goes from like 20, 40, 50, whatever. That's called relative VO2. It's called relative because it is relative to an individual's body weight. It calculates the body weight is included, so it's specific to their body weight. So if someone's like 200 pounds and someone's 100 pounds and the 200-pound person has a lower VO2 than the 100-pound person, you can't necessarily say the 100-pound person's in better shape because they have a higher VO2. And you can obviously if they're exercise and the 200-pound person just sits on the couch all day. But if they both are in shape and they exercise, you can't necessarily say that because a 200-pound individual is working with the VO2 relative to his body weight. So it's a little iffy. Now there's also absolute VO2. Absolute VO2 is in liters per minute. This is absolute VO2. And this goes anywhere from 1 liter per minute to 5 liters per minute. It's absolute to pretty much everyone because it measures it in liters per minute. So that's absolute to everyone. This is relative to a certain individual. But you just have to know this definition of an MET because I'm sure that's just a simple, you should never miss that question. It's very simple. Just understand what MET is. Now the conversions that you have to memorize are how to go from miles per hour on a treadmill to meters per minute. And that's just multiplying miles per hour times 26.8. Since 26.8 miles per hour, or 1 mile per hour is 26.8 meters per minute, so you just multiply it. Simple conversion. You have to memorize 1 liter is equivalent to 5 calories. Just memorize that conversion. 1 liter, 5 calories. In every single problem, I'll be doing these conversions. So, but if you don't know by now, you'll know by the end of the video. And you have to memorize some other ones that aren't that easy as Watt's formula. It won't be given. It's not really that hard to memorize this formula. It's kilograms minute meters divided by a constant of 6.12. This will be important when you get to cyclogometer questions. You won't use this formula for anything. It's for watts. So you use this on a cyclogometer. Simple conversion, I'll go over again on the question. The other conversion is a monarch butterfly revolution. Well, you really don't need to know. You really don't have to memorize that conversion. But the last conversion is to get kilograms per meters per minute. So to get this guy, that's just the resistance that the person's cycling at, whatever resistance it is, multiplied by 6, multiplied by their RPMs, or rate per minute. So simple conversions that you have to memorize. So now we'll get to the actual questions. So these are the 7 questions, and whenever you get a metabolic equation question, there'll be 3 on the test that you have to be able to do. So you want to be able to do these fast. They shouldn't take you more than 5 minutes a piece. They're really simple. Now in order to do this, you got to first look at the question, isolate any values. So 125 pounds, you take that, 6.5, write that down, 2.5%, write that down, And look what they're looking for. They're looking for METs, or METs is a volume measure of VO2. So that's what you're working with. So you write down everything they're looking for in that equation and isolate it. And now what I normally do is I write down what they're looking for. They're looking for METs. I write down everything I found in the equation: 125 pounds, 6.5 miles per hour, and also write down the thing. Great. And instead he's running. That's important to know what equation you're using. They're running. Okay, so in this equation you wouldn't really use pounds, but it's good to write it down and note it. But you're not using it because you only use pounds if you're trying to find out how many calories they're burning or how long they have to work out to burn a certain calorie. So when calories are involved, you use pounds. When it's not, you don't need pounds. Convert this to meters per minute by multiplying it by 26.8. You have to remember that conversion. See if I have this written down. Okay, I have it written down, so I'm going to do the conversion. 142 meters per minute. So that's that conversion. Now 2.5, just convert that to a decimal. Again, you just move 1, 2. So that'll be 0.25%. Oh, wouldn't really be a percent, it's a decimal now. It's 0.25, they're running. Okay, so these are the conversions you have. Now the equation for running, all the metabolic equations solve for VO2, relative VO2. Now, the running equation is 3.5 plus meters per minute. So that's why you need to get meters per minute multiplied by 0.2. Multiplied by 0.2, it's right there. And then you add this to the grade or the elevation. Elevation times meter per minute multiplied by 0.9. Or I think that's the walking equation. Let me check. I think I wrote it wrong. No, that's the right equation. Oh yeah, I did the second one wrong, sorry. So that's the right equation. This is the equation for running. She'll give you all the equations so you don't have to memorize them, but you just have to memorize the conversions. So if you plug in, I'll clear this, let's clear it. So solving for milliliters kilogram per minute, 3.5. I'm not going to rewrite everything, I'll just do some calculations right now. And we're taking meters per minute, which is 174.2 times 0.2. So, get my calculator on my phone, do some conversions. 174.2 times 0.2. That equals 34.4. 34.4 or 84. And then you calculate the other one, which is the grade, which is 0.025, remember, in decimal, times 174.2 times 0.9. Now that is 3.915. We'll just round it. And then you add these all together. 0.915, 34.84 plus 3.5. That equals 42.25. Not bad VO2, decent VO2 for a sedentary individual. So this is the relative VO2. But if you remember, the question is asking for METs. So you have to convert relative VO2 to METs. Now, one MET is 3.5 VO2, so just divide it by 3.5. And that gives you 12.07. And whatever, so the answer is they're working out at 12 METs. So that's the answer to number 1. Very simple. Now 2, now this is a more complicated one because whenever it's asking for how long or calories, you have to do more calculations. So again, mark what you have: 165, 2.5, 5%, 300 calories, and he's walking. So mark everything they're doing, and they're looking for a time. So, okay, looking for a time. So when they're looking for a time, you would use a weight. He weighs 165 pounds. 2.5 miles an hour is walking at. And he wants to burn 300 calories. So, oh man, 5% incline. So he wants to burn 300 calories. He's asking how long does he have to work out to burn 300 calories. Well, first you convert this to kilograms. Very simple, just divide it by 2.2. You should know that conversion by now for BMI. So 64 kilograms. 2.5, multiply that out, whatever that equals. Let's do 2.5 times 26.8. That will be 67. Oh, did this one wrong then, that's 67. 5 divided by 2.2 equals 75. Okay, so that's 75 kilograms. Try and go by my notes instead of doing the calculations. Okay, and this will be in decimal form, will be 0.05. Now, plug into the walking equation. The walking equation is pretty much like the running equation, but it's using different numbers. In grams per minute, 3.5 plus meters per minute. Instead of timesing it by 0.2, now you times it by 0.1 plus meters per minute. Well, actually, do a grade first, but whatever. Grade. Now you're timesing this by 1.8. Again, she gives you the equation, the formulas. You don't have to memorize the formulas. And then now that's the formula. Got all the variables. Now let's calculate it all out. So we had stupid phone. Okay, so we have calculator. Okay. Wow. Okay. We have 67 meters per minute times 0.1. That is 6.7. So just leaving out what it's solving for, but plus 6.7. Because meters per minute, 67 times 0.1 is 6.7. And now do the other part of the equation, the grade 0.05 times 67 times 1.8. That is equal to 6.03. Add these all together. 6.03 plus 6.7 plus 3.5 is 16.23. So they are working around 16.23 milliliters per kilogram per minute. Now this does not solve the equation because you're looking for time. So how would you get this to time? Well, you have to cancel milliliters per minute, and you also have to cancel kilograms. So in order to do this, you have to do a few steps. In order to cancel kilograms, you multiply it by how much he weighs, which is 75 kilograms. This will cancel kilograms. Now after we do this a few times, this will be very easy to do. That will be 1,217 milliliters per minute. Remember, you're trying to get it into minutes, see how many calories per minute, see how many calories are burning per minute. Now in order to convert that to liters per minute, that's the formula we have, is 1 liter per minute equals 5 calories per minute. You would divide it by 1,000, since there's 1,000 milliliters in a liter. Do that. You would have 1.217 liters per minute. We have a formula that conversion that 1 liter per minute equals 5 calories per minute. So you times it by 5, whatever, times it by 5. This equation shows that he is burning, at this intensity, working on this VO2, he is burning 6.08 calories per minute. Calories per minute. Now you're still not done. You know he's burning 6.80 calories per minute, but the question is asking how long does he have to work out to burn 300 calories. So you would just take 300 calories divided by 6.08, and you will get to whatever the answer is. 0.08, yep, and you'll get 49.3 minutes. So he needs to work out for 49.34 minutes. And that's that one. Going back to the third question now. Third question is a little complicated. This is as hard as a question will possibly get, is the third question. Market 150, terminal is 300 calories, 45 minutes, 3.5 meters. He's looking at elevation. Okay, so write down everything you have. It's 150 pounds, 300 calories. He wants to work out for 45 minutes. Running or walking, I guess, 3.5 miles an hour. What elevation does he need to work out at? Now, do all your conversions. 150 to divided by 2.2 to get to kilograms. 300 calories I want to convert, 45 minutes I want to convert. You have to convert 3.5 miles an hour to meters per minute by multiplying by 26.8. Okay, so these are all your variables. Now, once you plug this into a formula, you'll see a problem with this. Plug into the formula what you're solving for, milliliters per kilogram, writing that wrong, but you know what it is. 3.5 plus meters per minute, so it's 93.8. He's walking, so 0.1 plus grade we don't have, so we'll say that's x. It's a variable, we don't have it. Multiplied by meters per minute, multiplied by 1.8. Now, what's wrong with this equation? You notice this equation from algebra, you can't solve an equation if there's two missing variables. So you're missing relative Vo2 and you're missing grade. So what would you do? First, you have to calculate relative Vo2. Now you have calories per minute and you have how much minutes he worked out. So pretty much we'll be doing what we did on the second equation, but working backwards to get to calories per minute. So we have 300 calories. He wants to work around 45 minutes. So in order to work backwards, if you remember everything we did last time, we did calories divided by how many minutes. So you have to work backwards. So you divide 300 to see how many calories he burns per minute first. Okay, that's 6.66 calories. So we know he burns 6.6 calories per minute. Now we also have to work backwards again. Now we have to go to liters per minute. So that's dividing by 5. And that is equivalent to 1.33 liters per minute. Now we have the liters per minute to milliliters per minute. So multiply that by 1,000. So we have 1,333 milliliters per minute. Now we have to get kilograms in it and count his kilograms. He weighs 68.18 kilograms. So divide it this time by 68.18 kilograms. And that equals, do I have this written down? I do. That equals 19.55 milliliters per kilogram per minute. So essentially what you did is you use his calories and you use his minutes and you work backwards to find out how many calories you burn per minute, find out how many liters of minute that oxygen, blah, 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 blah. So you work backwards. I will just keep doing this in order to get used to it. So you work backwards. And now you can plug and chug. I'm not going to write down all the plug-in chugs, but the answer is 3.9%. So if you have 19.5 milliliters per minute, I guess we'll do it for the people that need to see it. Let's say we have 19.5. You have 3.5 plus, do the formula, 93.8 times 0.1 plus, you're looking for a grade, so we'll say x, times 93.8 times 1.8. So what you would do here is this is just algebra. You have to know basic algebra. But let's do it anyways, for the hell of it. 93.8 times 0.1, that equals 9.38. 9.38 plus 3.5. That equals 12.88 plus this x plus in parentheses 93.8 times 1.8. Now remember in algebra you got what you want to get x by itself, so you'll subtract 12.88 from each side. 18.5 minus 12.88, that equals 6.62 x. We'll put it in parentheses since we're trying to get x by itself. 93.8 times 1.8. 93.8 times 1.8. That's 177.84. And then you divide 6.62 divided by 177.84. That is equivalent to 2.037, and you move the decimal twice, so 3.7. So you would work backwards, and let's do that one. Now that is the hardest variation of a metabolic equation you get, and the rest of my metabolic equations are very simple. Number 4, I guess I'll go over. It's 11 METs max, so you know his max VO2. And it's just asking for how much miles per hour he has to walk. Now, if you notice, there's nothing that says grade. There's no grade in it. So you're just trying to find out miles per hour. Okay, so easily convert this to VO2, to relative VO2. So what we would do is just 11 times 3.5 is 38.5. Okay, so really that's all you have to do. 38.5, plug in your little equation, plus grade you don't know, so we'll say that's x again, multiplied by, what is this guy doing? Oh, this guy walking or running? He's running. So he's running, so you multiply it by 0.2. Now the other part of the equation, since the grade is non-existent, the grade is 0, you can cancel the rest of the formula. And now you can just easily do 38.5, subtract 3.5 to clear that. So it's 35 equals x times 0.2, you divide by 0.2, and 175, so 175 meters per minute. But the answer, the question is asking it in miles per hour. So you just divide it by 26.8 to get into miles per hour, and that'll be 6.5 miles per hour. That is the answer. Clear? Okay, 5 is using your arm ergometer, so it's a different formula for 5, but it's pretty simple. It's asking how many watts do you expend when the resistance is set for 2. Looking for watts, 60 RPM. So, looking for watts. You know it's at 60 RPM, so 60 revolutions per minute, and he's using 2 resistance. So, just got to memorize the formula for watts. That's one of the calculations you have to memorize. And watts is equivalent to kilograms, meters, minutes, divided by 6.12. Well, that's good and all, but you don't know what kilogram meter per minute is. There's another formula you have to memorize for kilogram meters per minute. Kilograms per meter per minute is equivalent to the resistance, which in this case is 2, divided by the RPM, which is 60, divided by 6. 6 is a constant, so just memorize this formula to get kilograms per meter per minute. So there's a few formulas, a few conversions you have to memorize. So you do that math, whatever the hell that is. That is equivalent to 720, and then you plug into that formula, 6.12, and you get your 117 watts. That's the answer. Now going to number 6. Number 6 is pretty much an ergometer also. It's kind of asking for the same thing. Yeah, now it's asking for calories, and now this is the equation, this equation that she gives you. Now mark 185, mark 600 kilograms, mark 20 minutes. So he's 185 pounds. Already forgot numbers we marked. 600 kilograms, meters, minutes. What else am I doing? Oh, he was working out for 20 minutes. They want to know he wants to know how many calories he burns in those 20 minutes, and he's on a cycle ergometer. So this is an equation that she'll give you also, but you have to memorize the conversions, of course. 95, convert that to kilograms, always kilograms. And that's really all you can convert right now. Now the formula is milliliters, so relative VO2. This time it's 7 instead of 3.5, plus kilograms, meters, minute, times 1.8, divided by his weight in kilograms. That's very important to note that this is all together. So just plug into the formula, 600 times 1.8 divided by his weight in kilograms. That equals 19.84 plus 7. I guess I already did the plus 7, so it's 19.84. Just looking down what I wrote down. It's VO2, and then that's milliliters per kilogram per minute. So that was very simple, wasn't it? But you have to find out how many calories he's burning per minute. So you do the same thing you did with running. So you would times it by his weight. So 19.84 multiplied by his weight to cancel kilograms. That is equivalent to 16.8 milliliters per minute divided by 1,000 to cancel milliliters. So you got liters per minute multiply by 5 to get how many calories he's burning per minute. So he's burning 8.35 calories per minute. And then he's working out for 20 minutes. So multiply by 20. And that'll give you 166 calories per calories. Now I realize I'm going pretty fast, but this is all plug and chug simple algebra. So no reason to focus on it too much. Now, number 7 is kind of asking the same exact thing. A little different. You have to do one more step. But it's asking for METs as a 110-pound woman when she pedals. And now instead of getting kilograms per meter per minute, she's giving watts. So remember the formula for watts. 50 watts. She's 110 pounds, so convert that, that's 50 kilograms. And they're asking for how many METs. Now, it's the same formula. So we'll say relative Vo2, kilograms per minute, 7 plus kilograms meter per minute, the same formula, times 1.8 over her kilograms, she's 50. You have to find this guy. If you remember from, okay, we're walking down the stairs. So, hornet right there. If you remember from the formula, let's see how well I remember these conversions, since I don't have my paper. But if I'm from the equation, kilograms per meter per minute is equivalent to, watts, kilograms, meters per minute, this is one you have to memorize, over 6.12. 50 divided by, or 50 times 6.12, I'm not sure what that is because my phone is near the hornet, I don't want to go to. But you find out whatever that equation equals, that equals kilograms per meter per minute, times that by 1.8, divided by 50, plus 7, and you get kilograms per meter per minute. But they're asking for METs, so you have to convert that to METs by dividing by 3.5. Not sure what it equals. And then the last one is very simple. How many kilocalories will this person burn when he steps on 25 centimeters for 15 steps per minute for 20 minutes? Stepping is retarded, but they're asking for that. Now, there's a certain formula for stepping. Let's see if I memorized it. It's milliliters per kilogram per minute. It's 1.33 constant. It's times something else, don't remember. And then, okay, I have to go there, risk my life to do this. Okay, we're safe. So, it's 150 pounds is how much they weigh. 150 pounds, the stepping out, the bench weight is 25 centimeters, they're stepping out 15 steps per minute. How many calories do they burn? Convert this to kilograms like we've always been doing. Now, for steps, you have to get it in meters. So you convert centimeters to meters, just move the decimal over 2. So it's 0.25 meters. Okay. So it's 1.33 times, okay, so 1.8. That's what, times 1.8 times the steps in meters. So it'd be 0.25. And then plus 0.2 times how much steps they take per minute, which is 15. So simple plug and chug. Do this equals 11.97, I believe. Oh, forgot, plus 3.5. Always plus it by 1 MET. That equals 11.97, I believe. Is that right? No, that's not right. That equals 8.97, this guy. Plus, wow, I'm doing horrible over here. Okay, now there's a baby wasp. What the hell's with this place? But do all these calculations. I'll actually get my phone out now. Okay, so it'd be 1.33 times 1.8 times steps in meters, 0.25. That's not correct. Let's do it again. 1.33 times 1.8 times 0.25. What is going on over here? Oh, forgetting something. Going too fast. Also times this by steps. Okay, so let's just clear all this. So it's 1.33 times 1.8 constants times step per minute, which is 15, times the distance, so 25. Okay, so that's better. Again, she gives you this formula, so I'm trying to memorize it, but she gives it to you. It's 15. You just have to remember to convert centimeters to meters. Okay, so that is 8.97. 8.97. And the other part of it is 0.2 times 15. That's, I believe that is, I don't know in my head. I want to say 3. Yeah, that is 3. So that's 11.97. And then you have to plus it by 3.5. And that equals good old 15.47 relative Vo2. You have to do the same thing to get into kilocalories or calories per minute. So 15.97 milliliters kilogram per minute. Get it into milliliters per minute by timesing her body weight. How much does she weigh? She weighed 68.8 kilograms. 68.18 kilograms. That will cancel kilograms. Fucking wasps. That will cancel kilograms. That is equivalent to 68.8. Okay. 15.47 times 68.8. That is equivalent to 1,064 milliliters per whatever. So 1,064 milliliters per minute divided by 1,000 to get to liters per minute. Do that conversion in my head. To get to liters per minute multiplied by 5. That's not correct. Multiplied by 5. So she is burning 5.66 calories per minute. I believe she is working out for, I think it was 20 minutes. I'm not sure. I didn't write it down. So 20 times 5.66. And she is burning 113 calories. That's not correct because I have 105 written. So maybe it wasn't exactly 20 minutes. I don't know. But essentially, that's a simple plug and chug. The hardest one would be question 3 because you have to work backwards. And just really memorizing the formulas. We'll quickly go over the conversions again in case you didn't get them after 20 minutes of me talking. But miles per hour, it's meters per minute. You just have to multiply it by 26.8 to get to that. Grade to decimal, that's simple. Don't know any other hard one. Okay. The one you have to memorize is watts. Formula, that's kilograms, meters, minutes, divided by 6.12. To memorize the formula for this. This equals resistance. They'll give you these in the formula. Resistance times the RPMs times 6. That's a constant. You have to remember to go centimeters to meters. That's a very simple. I won't bother writing that down. Remember that 1 liter equals 5 calories. I think that's really the only important ones you have to memorize. She'll give you the formulas, of course. You don't have to memorize the formulas. Okay, that's really all that's important. That is the ones you have to memorize, and of course you'll have the exam. You'll have to solve 3 metabolic equations. They'll be just like this. If you can solve all 8 of these, review this video, whatever. If you can solve all 8 of these, you can solve any metabolic equation. It's just different values, whatever. It's like if you can solve one calculus problem, you can solve any calculus problems. Actually, I don't know. I don't know calculus. But you can solve one problem, you can solve all of them. So, got 3 equations. They should not take you more than 10 minutes for all 3 of them. If they do, keep doing this video. Do all 8 of these until you can do them in like 1 minute. That's pretty fast, actually. 2 minutes. Give you 2 minutes. So you can do all of these in 2 minutes. That'll be perfect. Then you're ready. And you can't Google metabolic equations because there is no examples online. I've already looked. Trust me.